Hi folks, I'm going to talk a little bit about GraphQL APIs for data. My name is Tanmai, I'm the CEO co-founder at Hasura. Hasura is an open source infrastructure project that allows you to create a GraphQL API easily on top of heterogeneous data sources. And a lot of the content of this talk is inspired by the work we do at Hasura and learnings from our users, especially in enterprise, as they mobilize their data and start to use GraphQL increasingly to make the experience around their data APIs much, much better. So the rough context for this talk is that data is kind of increasingly getting fragmented and spread across multiple types of sources. And we need an API to start to access that, right? You might have data that is transactional data or data inside a SaaS service, right? Or data that is more analytical. And within the same application context or within the same user context, right? All of the data that is kind of split across these different types of sources is increasingly connected and relevant to the end user at the same time, right? Even if you think about a simple e-commerce application, not only are you making transactions and interacting with data, but you're also searching through catalogs. You're also looking at aggregate analyzed information around, say, recommended products, right? And these are kind of things that are all interconnected. And from an API experience point of view, you might need that to all come together into one API experience. When we think about this API, that's kind of the bottleneck because somebody needs to build this API, somebody needs to talk to multiple different types of sources, and you need to make sure that the API is continuously keeping up with the underlying evolution that's happening. And of course, you want kind of an API experience that guarantees a certain amount of performance and security to you, right? So in this context of having a data API where data is getting fragmented, right? The stuff that we want as properties that we want from a data API are kind of the properties that we want for any API engine. But specifically, what we want to make sure is that we're able to represent our domain models well, their evolution, their interconnectedness, right? We want to make sure that we have certain types of APIs that are, again, usual for data APIs, whether it's queries or streaming kind of information, right? Certain ways of interacting with that data, methods on that data, and certain NFRs that are important to ensure that this data API is ready and usable for production. Most importantly, we want to make sure that the API tooling, the infrastructure for our API consumers is top-notch, right, and keeps evolving well too, right? If you're able to kind of solve these problems well, these types of problems well, we essentially have a nice data API that is going to be easy to maintain and going to be easy to evolve, right? So if you think there's lots of topics here, right? And so we'll kind of focus on mostly the modeling aspect and the API aspect for the purpose of this talk. Let's take a look at how GraphQL can kind of add value here when we think about the data API, right? And again, most of you would know, but just to kind of reframe some of those properties of GraphQL in the data API context, our data is interconnected. And so GraphQL represents that reality of a semantic graph of interconnected models much better than us thinking about resources that are siloed in, that are evolving kind of independently, right? GraphQL is JSON native, which is again nice from an API consumption point of view and offers us an opportunity to kind of centralize some of that infrastructure around kind of the JSON conversionness of when we're kind of interacting with data. GraphQL also has modern primitives around streaming in real time, which is again useful because data is starting to be less at rest and a fair amount of our data is also in flight in real time, right? And then of course, GraphQL offers, GraphQL API always has a schema as a built-in artifact, which means that a lot of our challenges around API infrastructure, tooling, documentation, onboarding, are kind of automatically addressed, right? It's not 100% done, but a huge part of it that we would have to do manually if we weren't using GraphQL is kind of addressed, right? So it offers certain benefits around what we'd want from our data API and offers certain opportunities to centralize some of those concerns and the way that we think about our data that is split across a mesh of sources. So typically when we were designing and when we would design an API, the way that we would think about it is that we'd have models, we'd have getters or accessors of those models, right? So if I had artists and albums, music database, I would have a get method on an artist, right? Or where I might specify an ID as a parameter, right? Or I might have a list of artists that I fetch with the pagination parameter, right? And then I would have certain commands or methods that I would invoke that affect those models, right? And if we were thinking of it more as a CRUD style thing, then we would have a model. The same model is a read model and a write model. So we might post, put, patch, delete a model, we, or we might get that model, right? But if you're thinking about it more from a CQRS point of view, then we'd kind of think of it more as, we have commands that we're invoking, and then we kind of invoke commands. Those can be create user, create artist, process artist, add album to artist, right? Or add label to artist or whatever. And those would be kind of commands that we invoke. And our models would be read models that we would kind of expect our commands to affect, and then we would read data from those models, right? And so that might be a slightly different API. Now, when we kind of bring these ideas to GraphQL, the way that I like to think about it is kind of bringing that kind of CQR style thinking into our API design. So we think of read models first. So we have read models. Read models can be within the same source or within the same domain, data domain, or split across data domains. And these would have connections, right? These would have semantic relationships within the domain or across domains. And these would essentially become types in our GraphQL schema, right? We still haven't defined the methods, and that's what we'll come to next. The first category of methods that we can have are queries, right? And because it's a data API, there'll be certain common expectations and conventions that we can set up around. Are we fetching a single element, a single model, a list of models, paginating through them, ordering them, filtering through them? Aggregations especially are important for data APIs, right? So we can start to create kind of a convention that says, once we have a read model, these are the common set of methods that we can have for reading those models, right? And that kind of addresses the query side of our API. And now when we think about kind of maybe a more the right side of our API, especially when we think about GraphQL mutations, right? Maybe certain queries as well. When we think about GraphQL mutations, then the way that we think about it is that, hey, we'll invoke a command. The command will go do something, but eventually it'll return a reference to a read model or to a list of read models, right? And that kind of gives us a way to think about designing the right side of our API, the GraphQL mutation side especially. Although, like I said, some commands might also be query commands. But the same thing, the same idea, just revisualizing that in the context of multiple domains, right? We might have multiple domains. Each domain has models, commands, right? And we use that to create our GraphQL API, right? So at this layer, at the GraphQL API layer, we can start to centralize some infrastructure in the way that we map these models, bring them into types, in the way that we create common read APIs across these domains, and in the way that we invoke certain commands. So if you're able to centralize the infrastructure here, right, then we can kind of extract all the benefits that we would get out of a GraphQL API. We can centralize a lot of the effort that we're putting into building the API, and we can focus more within each of those domains. We can focus on the modeling. We can focus on the actual logic that might run and affect those models, right? So what we're going to dive into next is just kind of going a little bit deeper into that model mapping, into the APIs, the read API and the write API a little bit, just to see what that might look like, right? So let's get to models. When we think about models, the most important thing is to be able to map kind of what we want on the model that we want to expose, the models that we have within our domain, right? So if we have a database type domain, right, we'll have typically physical models. These data models might be physical models, they might be tables, right? Or logical models where the exact data in the table doesn't actually correlate to the model that you want to have in the API, right? So you might have a physical model or a logical model, but these are basically getting represented into a GraphQL model that you'd want at the end of the day. If it's not a database, but it's more like a source, you might have a model that's coming in from an API service, right? So the mapping layer that we have in our GraphQL infrastructure, code, framework, configuration, whatever it is, should kind of help solve this mapping problem to bring in certain models from a data domain, from a data source as easily as we can. The second thing that we want to do to make sure that we want to represent, right, that we want to add configuration around or code around is to make sure that we can model relationships between these models that we have, right? And because it's finally going to be JSON, the way that relationship will show up in the API is going to be, maybe you have a nested array, a nested object. So you have like many to one would be a nested object, or one to many would be a nested array, right? Or you can even have fields that are actually a relationship that is coming in from a different model, right? And each of those models should also have authorization rules that determine what fields are accessible and what entities of that model are actually readable by a particular API consumer, right? So these three pieces of work: mapping, relationships, and authorizations policies, right? This is kind of the bare minimum information that we need to bring a model from our data domain, right, from one of our data sources, right, into the API, right? And at this point, we now have a nice way to think about the types of our GraphQL schema and the way those types will show up, right? Not all of the types, some of the types, right? And the way that will show up. So that's kind of the first piece of the data API that we've kind of gotten sorted. And if you look at these examples that I have here, where I have type artist, right, I'm seeing that my GraphQL model is ID and name. In the physical model, it might actually be first name plus last name. My API model, my GraphQL model, I would like to be name. That's my read model, right? And then I might have albums, right? Or the artist has a label. The artist is signed on a label, and the label might have its own information, right? So that's a nested object. The artist has multiple albums, so that'd be a nested array. So albums and label would be kind of different models and have relationships to the albums model and the label model, right? And here is where I've done the mapping of the artist model itself. So we're seeing the mapping portion, we're seeing relationships, right? And then of course we'll have authorization rules that determine what fields we can actually access. So this is kind of how it will show up in the API schema, which is nice because now we can see kind of what our different interconnected models are, right? The second piece is reads. So what we want to do is create conventions around how we're going to read these models, right? So we can create conventions around pagination, around ordering and filtering, right? We'd want to create a convention around aggregations, and then we'd want to compose them with relationship. We'd want to represent those relationships in our queries, right? So we'd want to be able to read models across relationships. We'd want to also make sure that our queries can represent aggregations or ordering or filtering that can reference parent and child objects, right? So let's take a quick look at, as an example, I'll just show you kind of the way we think about it at Hasura and what that read API looks like, what that read convention looks like when we think about with the Hasura, the way that we think about it at Hasura, right? So I have here a demo app that's running on my machine, and I've connected in a Postgres source and a SQL Server source. These are kind of my two data domains, and I have a model called artists, right, which has ID and name, right? And so we're seeing kind of that information come in here. Let's take a look at what the API looks like. So I have pagination, right, and so offset-based pagination or cursor-based pagination. We have a way of filtering stuff. So we can say limit 10 and order by name descendant. That's what our ordering API, sorting API looks like, right? And then of course we have a filtering API as well, and we can filter on different properties. So we can say where, name, like, let's say anything that starts with a Y, right? So we have these kind of sorted. That's kind of for the filtering API, because that's kind of a convention around a list of models, right? So we're fetching a list, and this is the way that we want to have certain arguments in fetching a list, right? Similarly, a convention around aggregations, in the way that we think about aggregations is that any list of models that are fetched can have an aggregate applied to it, and with a certain set of aggregate functions that again can be added on for different types of models for different types of sources, right? So for example, I can do a count. So I can do a count to see how many artists I have in the system here, right? All right. Let's take a look at relationships. So we have artist ID and name, and let's limit this to 10. And now I can fetch, let's say, albums that is related to. So let's say title. Oops. And we can see the titles of those artists that are coming in here. Artists and albums are actually in two different data domains. Just to show you what that looks like, my artists are coming in from a data domain, which is in Postgres, and albums are actually in SQL Server. So even though they're across two domains, I'm seeing kind of, similar kind of API that's allowing me to do things like limit, offset, paginate on the underlying field as well, right? In fact, I can start to bring in aggregations here as well, right? So I can say, I can start to count and run aggregations on a list, right? And the nice thing is that this kind of follows a GraphQL API convention where I can aggregate any list, but at the top level, or even if it's a property of a particular parent of a child, right? So I can see the number of albums that I have per artist, right? And this kind of allows us to represent aggregations neatly in the context of relationships that we also have. So our concepts are composing, right? And our conventions are also kind of composing as we work with it. So this is kind of one way to think about the read API design, right? All right, let's quickly move on to some other concepts, but this is just kind of one idea of the way that we think about the read API. Now the other side of the API would be kind of our the right side of our API, so mutations. So for example, we'd want to have things that we'd want to have logic that we invoke. Let's say, for example, something complex like creating a user that has to go through a bunch of things. We can create a user. The convention that we can have is that we expect our logic to return a reference to a user ID, right? And what our GraphQL system can do is take that kind of logic, the output of that logic, which is a user ID, a reference to the user model, the logical model that we have for user object. And so in the final GraphQL API, we'd expect to see a mutation that returns a user object and allows us to traverse the user object, the user model. And if it's a list, then that list of models. And again, those same concepts that we had from our read API that we can kind of bring into the response of a particular command, right? So that kind of slightly CQRS style flow is the way that we can think about how we bring in certain commands into our GraphQL API as well. We can create our own conventions around CRUD, right? Because CRUD actions are essentially also just commands that are returning, again, a single reference or a list of references. And we can also come up with a certain conventions around what we want to have for the logic that we have is written in different kinds of maybe it's written in different languages, right? It's embedded inside the database. Maybe it's just written as a serverless function, or it's invoked over HTTP or RPC, and that doesn't matter because that convention can kind of be the same. The GraphQL layer just has to make sure that it knows how to reference the read models that we had from our previous discussion and how to invoke commands and the new logic that we have from when we kind of bring in commands and mutation into our system, right? GraphQL also offers subscriptions. In the interest of time, I won't go into too much detail, but subscriptions can have, the way that we think about subscriptions is you can have live queries for subscriptions that are very useful to consumers when they're looking at latest snapshots of data, or you can have streams, which are very useful for larger lists of data or for events, right? Especially when you have a really large list where you have like 1 billion elements and you want to extract that information over an API. An API is a very nice way to do it, but 1 billion elements are really, really large, right? So you can kind of stream that data as it comes, or you can, even stream real-time information the way that you would stream events. And subscriptions offers a nice way to do both. The new @stream API, the @stream directive will also offer a way to kind of approach streaming larger lists. The spec is still evolving, and I think our understanding around streaming especially is still evolving because there's things like back pressure and stuff like that to also think through, which don't have a firm answer yet. But there's an opportunity to kind of provide this kind of value for a modern data API as well. So to kind of take a step back and just see what we went through, right? We thought about using GraphQL as a neat API convention for a data API, right? We saw some common usage patterns and how we can model those usage patterns for a data API. We see how those concepts compose automatically. We couldn't go into authorization because that's too much detail for this conversation, but authorization at a model level can also kind of be made to compose automatically as we think about our read APIs and our command APIs. When you think about this design and now kind of operationalizing it, right? The way I think about it is what is the platform work that we need to do to set up the underlying GraphQL infrastructure, right? So that we're able to benefit from these 3 or 4 ideas we discussed, right? The first piece of infrastructure is that if you're able to set up a good way for the maintainers of a GraphQL API or for the owners of a GraphQL API to come in and do model mapping and authorization, that becomes really nice because now we can start bringing in models, right? And we can bring in models securely. We can also then bring in the infrastructure to think about specific data source integrations so that our query execution can be optimized for different types of data sources that we're speaking to, right? And that piece can be a little bit decoupled from the model mapping and authorization piece, right? So that we're using the same semantic concepts, but we're compiling queries if that is the more effective way of doing it, or caching queries in request if that's a more efficient way to do it, right? And then, of course, the infrastructure that we also need to set up is deciding how we want to have communication with the upstream services, especially commands, right? So RPC or HTTP is necessary. Read after write semantics are also a key part of this, that you want to make sure that when you run a command and something happens, it returns a reference to a read model. You can actually read that reference. You won't get a stale read, right, or an outdated read. So that's an important piece that needs to also exist. But if we're able to set this up and we're able to kind of empower our GraphQL API owners with this infrastructure and let them and set this up, then essentially what we get is we get a GraphQL platform, right, that can then allow us to get some things for free, right? The first thing that we get for free is that all of the data domains that we have now, those data domains kind of get automatically exposed over a nice API that people really like, right? All of the metadata, documentation, GraphQL API tooling is built in because GraphQL is an API that people really like to use. But from the point of view of the builders, right, of this API, the owners of those domains now have more free time and flexibility to focus only on their domain, the models and the logic, and not the plumbing of how they're going to expose it over the API, because that part we've kind of been able to create common conventions for doing, right? So because we can externalize that, make that a common convention, and then work on this for free. I think at a very high level, right, we said this before, the amount of data that we have is just going to keep increasing and going to keep fragmenting. And so thinking about GraphQL as a way to attack this problem offers a nice way of thinking about this problem and getting value from that faster, and also kind of setting ourselves up for the future, right? The next 5-6 years are going to be crazy in just the amount of data that we have and the ways that we start to use it. And what I kind of really like about this is that this opportunity that we can use to standardize this infrastructure allows us to focus on the domain rather than focusing on the API itself. It's sort of the same thing. It's not really, it's just pushing where we're putting our effort into a slightly different part, right? Into saying that instead of building, deploying, scaling, and documenting APIs, because we use GraphQL as a way to standardize these things, can we now just focus on modeling the domain and creating the unique business logic, and that's all. That's the work that we do. We get kind of the API for free because it's a nice GraphQL API, right? So that's kind of the thought that I wanted to leave you folks with. Please do feel free to reach out to me. That is the end of my time, but please do feel free to reach out to me if you have any questions. Would love to kind of chat about how you're thinking through these challenges and share insights in using this kind of an approach, drawbacks of this approach, and what kind of benefits this approach results in. But that's me, folks, and do feel free to reach out to me on Twitter as well. Bye.